Welcome to qnawire.
From the gravitational force law, we know that the force between two massive objects is equal to the universal gravitational constant g, and in this case, the masses of the two objects are capital M, the mass of the Earth, times little m, the mass of the Moon, over the separation between them squared, r squared. And we also know that this force, the normal force that acts between the object, results in centripetal motion. So from Newton's second law, Fn is equal to man, the normal component of the acceleration, which is m v squared over r. So v squared is the tangential acceleration, and r is the separation between the two planets, or between the Earth and the Moon. So we can now equate these two forces. So what this means is that g capital M little m over r squared is equal to little m v squared over r. Remember, little m is the mass of the Moon. So in short, we have the Earth with mass m, and it has a radius big R, and the separation between the Earth and the Moon is little r. So if we look at this equation, the small m's cancel on either side, and we get that the mass of the Earth, capital M, is equal to r over g times v squared. And if we assume that this orbit of the Moon is circular about the Earth, then the velocity at which the Moon orbits the Earth is equal to its circumference, 2 pi r, over its period, tau. So what this means is that we can rewrite the mass of the Earth, the equation we had above, to r over g, and we replace v by 2 pi r over tau, and that's squared. So this becomes 1 over the gravitational constant g multiplied by 2 pi over tau, all squared, and we have r times r squared becomes r cubed. Now, we note that we are given values for the period of the Moon's orbit about the Earth, and so that's tau. Tau is 27.32 days. And so we convert this to seconds and we get 2.3604 times 10 to the power 6 seconds. We also have the separation between the Earth and the Moon, little r, and r we are given as 238,910 miles. So we convert this to feet and we get this to be 1.26144 times 10 to the 9 feet. So now we can substitute our values into the equation above, and hence we can find the mass of the Earth with this data. So the mass of the Earth, m, is 1 over g, which is 34.4 times 10 to the minus 9, and that's feet to the power 4 over pound second to the power 4, multiplied by 2 pi over tau, which is 2.3604 times 10 to the 6 seconds, and that's squared, multiplied by r cubed. In feet is 1.26144 times 10 to the 9, and that's feet, and that's per cubed. Hence we get the mass of the Earth in these units to be approximately 413 times 10 to the power 21, and that's in pound second squared per foot.